Hi, and welcome to Code Corner. This is a video series we do at Mayfield Renewables to talk about codes and standards as they relate to the solar and solar plus storage industries. Today, going to focus in on the 2023 NEC and specifically going to look at 705.28a. And so talking about power source output maximum current. So 705 is about our interconnections, so interconnecting multiple power sources. The way that we use it a lot in our PV systems is our PV systems getting interconnected with the utility. Could be a battery system connected with utility, could be other sources, doesn't have to be restricted to those, doesn't have to be utility even. So we are connecting multiple power sources together, and that's what we're going to be looking at. So when you're doing that, you're going to be looking at this at Article 705 in general, and specifically 28A, we are looking at the output currents for our sources. And so this is similar to folks that have been doing solar systems, 690.8. This is akin to that, where we're defining maximum current values based on what type of circuit we have, what kind of equipment we have, how we're controlling it. So we'll jump into that. As we're going through, I like to show the actual code language for you. So if you need to, I highly encourage you to just hit pause on the video, read through that language. Try not to read it at you. So if you need to look at that, take it in, and then we'll go through kind of what it's telling us, and going through the application sometimes can be very helpful. So let's jump into 28A, and you can see the language there. So this is all about that output maximum current value. So again, we are trying to determine, we have some sources of power, what's the maximum current value? And so that's going to be the baseline for how we're going to size our conductors, size our overcurrent protection, and be able to make sure that we're installing these systems properly. So there's actually three parts to 705.28a. So I'm going to go through them one at a time and kind of flash that at you. So the first one is probably what you're very, very accustomed to in terms of applying this, or how you're thinking about this. And so it's really the continuous output current rating of the power production equipment. And you see that it's at its nominal system voltage. So this will be the value if we're looking at, so we're on the screen, we're looking at some PV inverters, for example. This will be the value listed in the manual on the spec sheet. What is that continuous output current? And so that will be the maximum value. So again, this is similar, there's similar language actually in 690 about this. And really what we're just making this very generic about our power production system. So this could be, again, this could be a battery system, it could be some other alternative power source, but we're just defining that maximum circuit current. So that's one way that you can look at it, and it's probably the way that you're most familiar with. The number two in 705.28a talks about if you're controlled with an energy management system. So step back, we've done some code corners, we've done some content around 705.13 energy management systems. Encourage you to take a look at some of that stuff. But 705.13 gives us ability to use energy management systems to control the output of our power production sources, as well as the loads. But in this case, to define the maximum circuit current, if you are using an energy management system, it would be the set point of that energy management system. So if you have, again, we're showing you here on the screen, kind of this power control system is how it's being labeled here because we're controlling the power. The set points for those, the output of those inverters, if they are controlled by that listed energy management system, then that would be what the maximum current would be. And so again, that's setting that baseline for how we're going to size our conductors, our overcurrent protection, and being able to just set up the entire system properly. And then finally, there's a number 3 here. And number 3 talks about if you have sources that are controlled by an EMS, so again, the energy management system, combined with sources on the same power circuit, it's going to be the sum of 1 and 2. So really what this is telling us is you have some inverters, in this case we'll just call them inverters from our PV system, that are not controlled by an EMS. So we have some inverters that are coming in and are producing power, and they're going to produce that maximum power, whatever it is rated on that spec sheet. And so that would be part one. We also have potentially some inverters, some maybe the storage side of things are controlled by an EMS. And so those are going to be controlled by 28A2. And so we would use the set point of that EMS to define that. So if we have a combination thereof, not surprisingly, we're going to take those and we're going to add them together in order to determine what that rating is. So in this case, from that AC aggregation panel out to the main panel, we need to look at both what is controlled, what is not, add those together. That would become the combined output or the combined ratings of those conductors. So again, this is really looking at how to just set the baseline for sizing those conductors. As you move through 705.28, there will be some more rules on how to do it. We have other videos talking about 28 in more detail in our code corners. And so this is, just taking that and setting up that baseline. So hopefully that helps helps understand around that. And again, for those that are familiar with 690.8 is very, very similar. We're doing really the same kind of things here in order to establish how to move on to the next step. All right, so that pretty much does it for 705.28a. We have other content around the other parts of 705.28, so I encourage you to take a look at those as well. And we also have courses available on our website around NEC, fire codes, other topics that pertain to this. So those might be of interest for you. Take a look at those and see if it'd be something you'd be interested in enrolling in. And as always, love to hear from you. So if you have questions on this content or other code corners, feel free to reach out to us at these locations. Or if you have ideas for other future code corners, love to hear from you as well. So thanks a lot for tuning in, and we'll see you next time.